Okay, and guys, I think someone is constantly stopping the recording. So if you guys constantly stop the recording, then what's going to happen is that end of the day, you guys are not going to have the recording. Okay, so please make sure that you don't disturb the recording option, because I've already turned on the recording. So yeah, don't disturb the recording option as well. Anyway, yeah. So thing is that I chose mean over here and median in these two places because it makes more sense for me to do that, okay, with respect to the data set that I have. Because over here, in case of trade volume and transaction fees, what is going to happen is that I know for a fact that these things are always going to remain constant, okay. So I just want to make sure that irrespective of the increase or decrease, I take the median value. But the difficulty level of a bitcoin mining a bitcoin is always going to keep increasing with more and more trades, okay. So that is the reason why I've taken the mean of that, because I want to make sure that I reflect on the latest things as well. So yeah, that is the thing. So I clean my data set that way. And then once I've done the exploratory, so first what we did was we got the data set. After we got the data set, we read the data set. After we read the data set, we performed some exploratory data analysis to understand which possible input features I could use for my particular model. Okay. After I was done with the exploratory data analysis, I cleaned my data set. Okay. So all these steps are, very important before you create your model. So once I'm done with all of that, I come on to create my model. So over here, I've used something called stats models. Okay. So there's this module called statsmodels.api. So from that, I've used a linear regression. I've used a linear regression thing using from the stats models thing. So essentially so when I say over here, if you guys notice, so what I'm saying is that import stats models dot formula dot API as SMF. Okay. So over here, if you guys notice, I say SMF dot OLS. The reason, so OLS is basically my linear regression function, which exists within stats models dot formula dot API. So I need to call that. So that is the reason I say SMF dot OLS of. Then I mention what are the things that I'm looking at. So which particular, so if you guys notice, I say my formula is equal to Bitcoin market price minus all of these things. The reason I use this minus is because is I want to create a proper demarcation between my inputs and outputs. So this is my output, and everything from here is going to be my input. Okay, so that's what I'm saying. So I have a set of inputs, and I'm saying my data is basically coming from this data thing. Okay, so initially, if you guys noticed, I read the CSV and stored it in a variable called data. So I'm passing in that same data after cleaning it and all. I've made the changes required in the data itself, because if you guys notice, data off, right? So I'm referencing the columns within the data set. So that's why I'm just passing the same data, and I say dot fit. Why do I say this dot fit? So if you guys remember, we spoke about gradient descent and all that, right? So essentially the whole concept of linear regression is to find the best fit for your line. And the best fit for your line is found out using gradient descent and a lot of other things and all that. So we want to make sure that the best fit of things are found, and which is why we use the fit function. So once we use that, once we do this whole thing, your model now is trained over the data that you have. Okay. Now what we need to do is that we want to predict the value using the model that we've created. Okay. So now over here, one very important thing that we haven't done, if you guys have noticed, is we haven't trained the value explicitly on so if you guys remember, yesterday we spoke about training set, validation set, and we also spoke about test set. Okay. So we really haven't created any training sets and yeah. So guys, someone is muting my microphone. Because it clearly says that someone is muting my microphone. Please don't mute my microphone, because if you won't be able to hear me then. Anyway, So moving on. Yeah. So as as I was saying, it's basically this. So the reason we didn't, we didn't really use the training, testing, and validation sets here. Okay, and there is no particular reason for that. It's just an example that I wanted to show you guys. It could be done this way as well. So you could do that. Okay, so essentially you're training. The problem that arises when you use your entire data set for training is that you don't have enough points to validate and test your model. So you can't really predict the accuracy as such. Okay, and even if you do predict the accuracy, so you can actually, so what you can do is, obviously the line that you get is not going to be passing through each and every point. So you're going to have some or the other error. So the accuracy is not going to be 100%, obviously. But what is going to happen in that case is that your accuracy will still be pretty high, because this particular thing is a linear, linearly dependent function. So most of the points are going to lie on this particular line itself, or very close to this line. So always you need to make sure that you separate your data sets into two, at least two sets, which is the train and the test set. And if you're pretty confident about dividing your train set into validation set, then you can do that as well. So you can have 2 to 3 different sets of data to understand how your model actually functions. Okay, so don't worry, we'll be going through another example that shows how to split your data set into training and testing sets. Okay, so don't worry about that. We'll get back to that. That's not a problem. But anyway, yeah, moving on. So we've created our model over here. And now we are predicting the values within data itself using this particular model. So now what essentially is going to happen is that since we trained our whole data using this particular, since we trained our model using all the data that we had, the values that are going to be predicted are going to be pretty close to the data that has been used for training, because it's the same training data that we're putting in, right? And that is something you can observe using seeing the mean squared error. So usually in regression problems and all, your mean squared error gets pretty high because there are 1 or 2 points that go pretty out of hand, and the distance square is going to affect it a lot. Okay, but over here the mean square error is acceptable. It's pretty decent. It's like 406, which is fine. So so thing is that the reason why we so this way what happens is that I'm not able to understand the authenticity of my particular model. Okay, so just make sure that every time when you perform a machine learning thing, whenever you're working on any machine learning problem, you have a separate training set and a separate testing set which is different from your training set. Okay, you shouldn't include the points that you're testing in the training data, because your results will be biased. Okay, so yeah, then I just so I say model.predict of data and I pass all these inputs. Okay, and once I do that, I just find the mean squared error using the sm.mean squared underscore mean underscore square underscore error. So this is a function again which exists within sklearn.metrics. So I just get that, and then I get this particular value. Okay, so now if you guys notice, I've just predicted the values. Okay, and later I also computed this. The accuracy was pretty close. So if you guys notice the prices over here, I mean so these are basically the predicted values of a given day. Okay, and these values are extremely close to the actual values. So that's the thing. I mean, these values are pretty biased because we are using the same data that we use for training to test the model as well. So this is not how it should be done, to be honest. Okay, this is just an example for me to show how you do the exploratory data analysis and what you shouldn't be doing with respect to your data sets and all that, and what you can do with respect to your data set, how to create a model and all of that. Okay, so yeah, I mean, this was just one particular example. So do you guys have any doubts in this particular example?
Yeah, hello.
Yeah,
Rahul. Adeshan here.
yeah, go on.
Here in your project, you didn't use NumPy, right? So, like, and I want to know what is the basic difference between NumPy and Pandas.
So NumPy is basically called so thing about NumPy is that it's the short form of numerical Python. Okay, so pandas is a proper data manipulation thing. Okay, so you can manipulate a lot of data points. You can gather data from data sets, okay, from CSV files, Excel files. You can group these data together and all that, okay, using very simple lines of code. But in case of NumPy, what happens is that NumPy is more of a mathematical library. It's not a data manipulation library. Okay. And over here, yes, as you mentioned, I could have used NumPy in one particular place, and that is over here,
Yeah.
this particular place where I'm, filling the NA. So
Yeah.
this fill NA, I have, a way to, fill NaN values even in NumPy. Okay. But I chose to go with pandas because pandas is more friendlier and it's more simpler to invoke. Okay. You can still use NumPy in certain cases, and there are certain cases where you actually need to use NumPy. But again, that depends on the problem that you're trying to solve and what you're trying to do. So it depends on the necessities of, what needs to be done. But there is no, I mean, I wouldn't say there's no relation, but there's not a lot of relationship between pandas and NumPy because they cater to different needs. Because pandas is used specifically for data manipulation, whereas NumPy is used for numerical Python problems.
Okay. And one more thing. Here you have imported linear regression by stats model.api.
Yeah, we can also
So
do it using sklearn.
yeah, SQL, yeah. So what is the difference between those two? Like, is
Nothing.
it
It's the
the
same.
same?
It's
Yeah.
the same thing. Yeah. It's just that I was I just wanted to say that there are multiple
Yeah.
modules or libraries that you could use. Okay. So you also have linear regression available in sklearn, and in fact, linear regression will be available in various other you know
Yeah.
modules as well.
Yeah.
So you can use any of it because all of them have the same implementation.
Yeah. Here, is there any need to build a GUI? Basically, in my internship, we build the GUI on Node-RED. Okay.
I'm
So
sorry, I
that
can't hear you properly.
yeah. Uh, did you build a graphical user interface?
For this particular project, no, I mean, there's no necessity to build a GUI, right? Because essentially this was more like a data science thing for me. So, I mean, GUI, you don't need to always build a GUI because end of the day, as machine learning engineers, data scientists, and all these things, what you're going to do is that you have certain, you have some information that you get and you need to present it. So I just, use graphs and all, but I've never really built any GUIs for my things. But you can always build a GUI. That's not a problem. I'll show you an example where I built a GUI for, a model that I built. So it was basically taking inputs from the user and it was a machine learning model that I built. But I'll show that eventually if we have time later, or you can just message me and as well just be sharing that code with everyone. So, you guys can understand what exactly is happening there.
Yeah, sure. Thank you.
Yeah. Yeah. Any other questions, anyone? Okay, great. What about the others? No. So, in fact, if you guys notice, so to answer your question, there are a lot of fields over here, right? But in my particular linear regression model, I haven't used all of them. So I've just used one, two, three, four, five, six, seven. I've just used seven features. So yes, I mean, I did neglect the features with low correlations. Yes. So I didn't consider all the features. So I just considered those features which had a high correlation because it doesn't make sense for me to, No, exactly. It won't affect my effectiveness. In fact, it's a good thing because there's something called overfitting your model. Okay. So overfitting happens in two different manners. One, you can add a lot of features into your model. Okay. And your model starts getting confused. Or you might start training your model with so many data samples that your model starts getting confused. So one thing that you always need to understand is that you need to add the right, features into your model, and that depends on you, that depends on your domain knowledge, that also depends on certain mathematical measures like the correlation itself. So yeah, I mean, it doesn't really affect the effectiveness of the model. In fact, it improves the effectiveness of the model because you're not putting in redundant or unimportant information into the model to train it. Okay, great. So any other questions, anyone? Okay, so if we don't have any other questions, then we'll move on to the next problem. Okay, so the next example that I was talking about, it's called the Titanic survival predictor. So this is one of the most basic problems out there when people get started with machine learning. Okay, so this is like the first thing that people usually start off with. Okay, and this was the first thing that I started off with too. So I'll show. So basically, what this particular thing does is that we have a training set. Okay, the training set is basically a CSV file with. So essentially, we have different row names. Okay, we have a class, as in which class they were in the Titanic, what their name was, whether they survived or not. So if it's a one, it means they survived. If it's a zero, they didn't survive, and what their age was. Okay, so if you guys notice, as I said, a lot of people don't have ages mentioned over here. Okay, and we also have many other features like boat, their gender, the ticket, basically the number of the ticket, which room they stayed in, and all that. Okay, and if you guys notice, this room and ticket, they really don't have a lot of information. It's pretty much empty for most of the rows. Okay, so first, when you start doing some machine learning problem, or any data related problem, just visually go through the data set, see what it is, like what exactly is there within the data set. So I have genders, great. I have whether they survived or not, great. I have the class in which people were in, great. Okay, I have names, great. I have ages, I have where they're from and all of that as well. But I need to, I just want to make sure that I take the rows which are actually necessary for me. So end of the day, what I want to do is that I want to predict who are the people who survived on the Titanic. Okay, and I have various features over here, like the age, the class they were in. Okay, and their name, their gender, and all of that. So now I need to understand which are the best features for me to uh, you know use with respect to creating a model. So let's see what exactly is happening over here. So in the Titanic underscore predictor underscore, this is the training file. Okay. So as if you guys notice, I've imported NumPy over here as NP, pandas as PD, and I've imported from sklearn.ensemble. I've imported random forest classifier, and from sklearn.cross validation, I've imported train test split. Okay, so you'll understand what these two things are doing in just a bit. Okay, and in the process, I will also be explaining more about random forest classifiers and decision trees as well. Okay, so first I'm reading the CSV file Titanic underscore train. Then I'm finding so I had this age column, if you guys remember, in the data set, but a lot of ages weren't really filled up. There were a lot of empty spaces. So what I'm doing is I'm filling up the empty spaces, the NA fields or the NAN fields, with the median age. Okay, and then what I'm doing is that I've decided to take P class, age, and gender as my inputs, because this is, I think, a more trivial and more obvious thing that uh, the name of a person is not really going to affect their survival chances, and where they got into the embarked where they actually got into the Titanic also won't really affect their survival chances, and neither is the home destination or room or ticket number or the boat, because the boat is being it's just a very these are useless fields for us. So that's why I'm just using a very basic model. I'm just creating a very basic model using the gender, the age, and the class, because obviously the people who were on the you know uh, third deck are the people who majorly survived. If you guys notice in the first few values itself, people on the third deck are three people. Okay, and they already survived. Okay, three out of all the people in the third deck survived. So it means that the third deck was probably closer to the escape routes. Okay, and probably the other ones weren't as close. And similarly the age, obviously, if you're now if you guys notice, let's assume that this first this particular person was on the first deck, and the first deck wasn't really close to the escape route, but this person still survived. Okay, he was 49 years old, And obviously it makes more sense, right? Probably a person who was 65 or 70 years old. So over here, if you guys notice, there was another person on the first deck who was 65 years old, but that person didn't survive. However, this person survived. He was 49 years old on the first deck and he survived. So obviously the age also does matter because it talks about your agility. And at the same time, gender also might have some correlation because in the Titanic, what happened was that all the females were allowed to escape first, right? So obviously the gender also would have a huge determination on the prediction of survival or not. So that is why I used the gender, the age, and the class as inputs for my data set. Okay. So now if you guys noticed in the class P class part, our variables were in the form of third, second, and first. So one thing that you always need to remember, always, is that when you're submitting values into, a machine learning classifier or regressor, your values should be numerical of type. They shouldn't be any mixed types, or they shouldn't be of a string type. You should always send in numerical values. So that is why what I'm doing here is that I'm saying data underscore input of P class. So I'm selecting that particular column, okay, P class column, and I'm replacing all the thirds with 3, all the seconds with 2, all the firsts with 1. This just helps me to make things easier. So this way I just get proper numbers. Now um, I have data underscore input of sex. So what happens over here is that each and every person's sex was either male or female. So that is a string, right? So I need to, again, as I mentioned, I need to have only numerical values. So what I'm doing is that I'm saying, so NP is nothing but numpy. So from numpy, I'm calling this function where. So if you guys have done C++, you must be aware of the tertiary operator, right? So it's a question mark and a colon. So you can have three different values within that. So it's like you can put a condition in one, and if that condition is met, then the first value beside the question mark is taken, else the last value is taken. So similarly, we have a function called where in NumPy, wherein we're seeing if the data underscore input of sex is equal to female. So if it's a female in that particular row, then we're shifting, we're changing all the values with female to 0, and all the people who are males will be represented by the number 1. Okay. So that is just some cleaning and all that we're doing. So all these parts refer to the cleaning of the data set that we're doing. So one thing, if you guys notice, is that we haven't done any exploratory data analysis over here. In general, it's wrong, but then over here, this is a very basic data set. So I could just visually look at it and come up with something that could help me out. Okay. Now, what am I doing? So yeah. So now I need to, I'm splitting my data set into two parts, training and testing. Okay. So if you guys noticed in this particular thing itself, I had a Titanic underscore test.csv. So this is again another separate file that I have. Okay. But now if you guys notice over here, we're reading only Titanic underscore train.csv. And I'm using this train test split function to split my data into two parts. Okay. Input and expected. So essentially when I split my training sample into two different parts, I split it into something called the train set and the validation set. Okay. So essentially what I'm doing here is I'm passing data underscore input, this particular thing, expected underscore output, this particular thing. Okay. So I'm saying train test split of data underscore input, expected output, and test size is equal to 0. So basically I'm saying that my training samples would be 67% of my data set, whereas my validation sample would be 33% of my data set. And this random state is it's something called a hyperparameter. It varies with problem to problem, but you can just fix any value over here. In general, you can fix 1000 or 9999 depending on your wish. Okay. So yeah, so essentially what this particular train test split function does is that it splits your data into four different parts, because your validation set is going to be of 33%, whereas your uh, training set is going to be only 67% of your this data, right? So it divides it into four parts. And what are those four parts? So you have an input underscore train, which is basically the values that you get from the Okay, one moment. Is it clear now? Is the code clear? Guys, could anyone reply? Can you guys see the code properly? Okay, cool. Is this okay? Great, cool. So yeah, so essentially we're using this train test split. Great, cool. So we're using this train test split, and we're getting four different values. So if you guys notice, first this data underscore input is split into two different parts. One is a 67% part, and the other one is a 33% part, because 33% is going to be your test validation samples, which we are just mentioning as test samples over here. So we have this, and similarly the output also is going to be in the 67 33%. So once we've split it into that, we invoke the random forest classifier. Now, what exactly is random forest classifier? So if you guys remember yesterday, we spoke about something called decision trees. Actually, probability trees. We spoke about something called probability trees. So what happens is that in probability trees, you have one root node. Then you see whether a condition is met or not. If yes, you take a different path. If no, you take a different path. So similarly, what happens in decision trees is that decision trees follow the probability tree model. So it's a probabilistic model. Okay, when it comes to quantitative modeling. So you have a probability set of distribution, and then you pass in input variables. You try to see what exactly is happening at each step, and you try to pass it on. Now what happens in decision tree is that you just do this particular thing once. Okay, but in terms of random forest, what you do is that you take decision trees. So essentially what happens is that your data sets don't really have a lot of data points most of the times, majority of the times. So in such cases, when you have very less data points, you have a concept called bagging. Okay, so in bagging, what happens is that you have let's assume you have a circle full of points. Let's assume we have 100 points in the data. We have 100 points over there. When you use the concept of bagging, uh, your bagging model randomly starts picking about 75% of the data points, okay, from your data set, and it starts creating different data sets on this. Okay, so this way what happens is the number of data points that you have considerably increase, okay, because the combinations that you're using are increasing, and this is what is called bagging. Okay, so essentially what random forest does is it follows the concepts of a decision tree classifier and uses the bagging concept as well. So how it uses the bagging concept is that it takes in data, splits it into multiple datas, splits and it splits the um, so it, as I said, it follows decision trees as well, right? So since you have multiple paths that you can take, this particular random forest classifier takes in multiple trees at the same time, and it starts taking different bagged data sets into each of these trees. Okay, and then it computes the error, averages the error, passes it back, and this is done multiple times in order to see which particular trial gives the best error result or the least error result. Okay, so this is what is called bagging, and this is the concept that is involved in random forest classifier. So yeah, so we pass in the train test split stuff. We pass. So first we invoke the random forest classifier, and then we fit this particular random forest classifier to the training input and the training output. Okay, once we fit it, we want to check how good the accuracy is. Okay, so for that I use something called the rf.score. Okay, so this particular score function is something wherein I just pass the test inputs and the test outputs, and it matches these test inputs with the test outputs with the predicted outputs. Okay, so yeah, and then I get an accuracy. I just multiply that with 100 and I get a percentage accuracy. So this is, and then after that, what I'm doing is that I'm dumping this particular model. So this particular accuracy that I've found, this particular accuracy is not my test accuracy, but it's my validation accuracy, because the test values that I've got over here is from the training set, right? So when I get the test values from the training set, it's called the validation accuracy. Okay. So this particular accuracy is a validation accuracy, but now I need to test it on the test set that I have, which is Titanic underscore test dot CSV, right? So that particular thing is something that I need to test it on. So for that, I need to, I just need to run this particular, I need to predict the values using those particular inputs and see how what the accuracy is there for that. But before that, I want to store my model. So when I want to store my model, I use something called joblib. So joblib is a module again, a Python module, which has a function called dump. So the dump function in joblib allows you to, uh, you know, so it takes this model that you've created and you fit, and it stores that with the name that you have given. Okay. So that was basically the model creation part. Now let's go back to seeing how exactly are we computing the test accuracy. So we found the validation accuracy, great. But now we need to find the test accuracy. So now if you guys notice, we're performing the same steps over here as well, in the test set as well. Obviously, we need to perform the same cleaning stuff. So we do all the cleaning required, and then we use job loop to load that particular model that we had. Okay, so we load the model, and now we have this data underscore input, right? So we pass a test input. So if you guys notice over here, we're reading a different CSV file. We're reading the Titanic underscore test.csv and not the Titanic underscore train.csv. So the input is obviously going to be different over here. So we predict the values for these inputs and store it in a variable called predict. And then what we're doing is we have a separate file called results Titanic underscore results.txt. We just compare the results and find the accuracy of that particular we find the accuracy of this particular model. So this is again a very basic model, a very basic question. Okay, so it's a very basic thing that exists, and it's basically for people who are just getting started off with machine learning. Okay, so I just thought it'll be a nice example for you guys to understand as well, because I'll be able to link it to what we learned yesterday. Because essentially what is happening is that in random forest, if you guys notice, we had the class, okay, we had the gender, we had age and all that, right? So essentially what is happening is that, let's assume we started off with the root node, we ask the class. So class is like either 1, 2 or 3. Okay. And then we check the age. The age might, if it might be greater than, 30, or greater than 30, less than 45. Okay. Or something. So you can have multiple distributions. So all these things, although you don't explicitly define it, your random forest algorithm understands these things and it starts creating its own probability distributions depending on the data that exists. Okay, so all these things are hidden to you. The reason I wanted to explain all of that to you yesterday was because I wanted you guys to understand what is going on behind the scenes, because as I mentioned, it's very important for people who are getting into the industry to know what exactly is going on behind the scenes. Okay, so even over here, if you guys remember, I spoke about gradient descent, right? So over here, how is gradient descent happening? So if you guys remember, I told you there was this one step where you have multiple trees and multiple decision trees, and different bagged inputs are sent into each of these trees. No, I'm not talking about the code anyway. I'm just talking about things in general. That's why I zoomed out of it. So, um, yeah. So as I was saying, I'm sorry, I just forgot what I was talking about. Yeah. So basically what I was saying was that we have different aspects. Like we have this particular probability trees, and that is the reason why I spoke about those things. Now coming to random forest, what happens is that we also spoke about the concept of gradient descent. So in gradient descent, we spoke about minimizing the error function, right? Similarly, in random forest, I told you guys that we have multiple trees, and through each tree we are sending a different bagged input, because we are bagging multiple inputs from the train set itself. So we're sending these different bagged inputs, trying to see which of these gives us the best least error, and we're constantly iterating it. So that itself is again gradient descent. So if you didn't know about gradient descent, if you didn't know about probabilistic trees, then you wouldn't have understood the concept of random forest properly. Similarly with linear regression as well. That's why I covered the concept of quantitative modeling yesterday, because it helps you extend those concepts onto these machine learning and deep learning models. Okay. So this was the second example that I wanted to talk about, and I'm kind of done with the second example as well. So do you guys have any questions so far? Any questions, anyone? Uh,
Yeah, hello.
yeah. Go on.
Basically, this random forest is on classification. Right? So we have random forest regressor too. So how does it work?
I'm sorry, I couldn't hear you properly.
Yeah, can you hear me?
Your voice is very faint. Yeah, go on anyway.
Yeah, hello.
Yeah, I can hear you now. Go on.
Yeah, random forest is basically classification model, right?
Right.
But we have random forest regressor too.
Right.
How does
So
it?
random forest is not only a classification model. So it depends on the data that you're passing in. Okay. So if the data that you're passing in is discrete, then obviously you're going to have only a classification problem over there. Right. So you can only have a classification solution. So over there you'll have to use random forest classifier. But if you have continuous data and you're trying to understand what is the price range or something of something, then you can use random forest regressor. But when you use a random forest regressor, essentially you're not going to be using probabilistic trees as a quantitative model, but instead it's going to be a completely different approach. It'll be something similar to a linear regression function that you're taking, because you want to find an interval, right? You want to find a set of values, an interval between which the value might lie, a predicted value might lie. So yeah, that is the difference over there. So it depends on the problem you're trying to solve and the data set that you have. Sure. Okay. So so number one, when I talk about the splitting of data apart, it is definitely going to sound a little confusing. Okay. But trust me, when you guys actually try implementing it, it's going to be very easy. But I'll just repeat what exactly is happening here, because it's a very important thing when it comes to your machine learning models. Okay. So we have a data set over here. Okay. And we have read the input over here and we have read the output over here, and we've stored it in different variables. Okay. In sklearn.cross validation, you have something called the train test split. It's a function. So we take this train test split function, okay, and we split it into two different parts, which is the training part and the testing part. So if you guys notice, there are four different variables here: input underscore train, input underscore test, expected output underscore train, and expected output underscore test. Okay. The reason we have four different variables here is that this train test split function gives four different uh, guys. Does anyone have a doubt? Because I just heard someone unmute themselves. Anyway, okay. So this train test split function returns four different values. Essentially, for the input for this train test split function is going to be the input and the output that you're expecting. So basically, this data underscore input and the expected output are the two different things that I'm passing in as inputs to this particular function. And then I'm also saying that test underscore size is equal to 0.33. So it means, let's assume my data set is of 100%. 33% of my data set is going to be for testing. Okay. Whereas the remaining 67% will only be used for training. And then over here, this random state just tells what points to pick in random from your data set. Okay. So you can just fix this to any number and it's still going to be fine. So now when I do that, what is happening is that I get four different values, because this particular expected output is divided into a 6733 set, and this data underscore input is also divided into a 6733 set, which is why I have input underscore train, input underscore test, which is 6733% of the input part, and expected output train, expected output test is going to be 6733% of the output part. So that is what the train test split part does. So this is how you split your samples into two different parts. uh, did it give you a better idea, Saida? Okay, perfect. So anyone else, any other questions? Okay, so if you guys have any questions, then feel free to unmute yourselves and just go forward with it. And so there's this one last thing that I wanted to cover with respect to machine learning. Okay, it's about, can you please show the output? So the output is basically just going to be so there's no output as such. It's just going to be an accuracy. So the output accuracy that I've got is 82%. Okay. So I mean, I really haven't downloaded these things because these were on my other laptop, and I'm taking those sessions from another thing. But yeah, I mean, I'll just send you the code so you guys can always run it on your own things. Otherwise, you know what? Just give me a moment. I mean, it's just going to take a while though. So I'll just download this and I'll try to run it towards the end of the session. Okay. Anyone else? If you have any other questions, you can feel free to unmute yourselves and ask your question out loud, or you can type it out in the chat section. Yeah, so random, the best part about random forest is that you can use it for both discrete and continuous problems. But depending on the type of problems you're using it for, you'll have to use a classifier or a regressor. That depends on your data set and the problem that you're trying to solve. So classifier will be used in case you want to, get discrete outputs, and regressor can be used when you want to get continuous outputs. In fact, this problem that I just showed is basically a discrete problem. It's not a continuous problem, right? So obviously random forest will be useful for discrete problems as well, which is why over here in this case, we use a random forest classifier and not a regressor. Any other questions, anyone? And see, it's different from a neural network in a lot of aspects, okay? Because what happens in neural network is that you have a completely different concept of backpropagation. I won't be dealing with that right now because that's something that we have only for the AI part. So I'll be taking it up in upcoming sessions. If you've chosen AI as your track, then you'll be knowing more about neural networks over there. I mean, see, the thing is, it's all a step by step process. So just try to understand whatever is there initially, because we'll be developing on all of these eventually. Because even yesterday's session, if you guys noticed, I formed the basis of things and then I took it forward with algorithms that we saw today. So even the deep learning parts are going to be somewhat similar to that itself. So yeah, we'll be covering the concepts of neural networks in the upcoming session. So don't worry about that. Yeah, I do have an example of continuous data set where we use a random forest regressor. Um, I'll just show you. Give me a moment. I'll have to look for it though. Just give me a moment. Yeah, so over here, this is basically a stock marketing problem that we took forward, and over here we're using gradient boosting regressor and a random forest regressor. So obviously in stock markets, what is going to happen is that you're going to have continuous values and you want to predict the price, right? You want to predict a price range. So over here, I'm using, so it's a very lengthy project. Okay, so I can't really explain each and everything because we don't have that much time. But yeah, I mean over here, I'm using a random forest regressor in order to predict the continuous values as well. So I'll just show you the data set though. I'll show you how the data set looks. So we have stock prices for 50 different stocks, and we have various data like this. What is the opening price? What is the high price of that day? Low price, last price, the closing price? What is the trade quantity, turnover? So this is more like a continuous data type. It's not like discrete in terms of 0 1 0 1 0 1 type. So you have multiple values. So it can't be a discrete value. It can't be a discrete data set, but it's a continuous data set. So in this case, yes, we were using a random forest regressor. So I mean, anyway, this. So actually, the thing is, this is also going to be one of the projects that you people would be working on at DeepShiz. So those people who actually, you know, uh, would be pushed into this project would understand in depth as to what exactly is going on. 30, yeah, perfect. So you're welcome. Okay, so thing is that there's just one small thing that I wanted to, talk to you guys about, and it's about deploying your solution. Okay, so thing is that when you go into the industry and all that, it's not just about creating models, but it's about creating models and pushing it into production. Okay, so you create a machine learning model. How can you link that machine learning model to the backend or something like that? So this is one such example. Okay, so I created this project. It's called Mercalysis. So if you give a number of followers that you have and a caption, uh, this particular bot is going to be able to understand how many people your post is going to reach to on Instagram. Okay, it's a very basic project, so you can just go through. It's a huge project as well. Lot of things, lot of files, lot of folders. But yeah, over here, one thing that we did was we actually linked the front end we linked the front end with the back end, and in the back end we integrated the model as well, the machine learning model. So integrations are very important things. So integrations can be in various aspects. So you can integrate it. You can integrate your model you know, into a backend using Flask or something, or you can integrate your particular machine learning model into a chatbot and just put it up on servers like Zulip or Slack, things like that. So you have multiple options like that. So just make sure that you always are aware about how to deploy your solutions. And the reason why I showed you guys about this one particular part wherein we stored the model in case of the random forest thing was that one second, I'll just show you guys that line of code. Yeah. So if you guys notice, I stored a model over here using jobloop.dump. The reason I stored this was because I want to show you guys how to, uh, you know, so in case you want to invoke this on the back end and you want to you want to deploy your machine learning model, then you can simply connect to this particular model which already exists. So it's more like a pre-trained model that exists within a folder, and you can just invoke that and start doing your predictions using that particular model at production. So it's just a nice way to store your models and all that. So obviously in real time, what's going to happen is that you're going to get so much data on a daily basis. So it's going to constantly keep changing with respect to the models are going to keep changing with respect to the data that you get. So yeah, I mean, just remember that it's always important to have these aspects. Like you need to know how to deploy your solutions, and your deployment can be done in various aspects, like integrating it into a chatbot or just connecting it to a backend using Flask or Django, something like that. So that was just one particular thing that I wanted to take up. And that is pretty much it from my end. So do you guys have any other questions, or any questions about how the internship would take place and all that? The machine learning guys, because the machine learning guys, it's your last session today. So you won't have any other sessions after this. You would be starting your internship in a day or two. So do you have any questions about the internship or something like that? Guys, you can feel free to unmute yourselves right now and you can just put forward your questions. Yeah, anyone, any questions? So thing is that we generally don't do that until, so we don't share all the materials until we're done with all the webinars, and that's just a thing that we follow because if we start sharing the material, then people are not really going to concentrate during the webinars because we want people to listen to what is being said. So the materials and all, unfortunately, we won't be able to. Yeah, even the ones that we taught. It's just that now if I start sending you the material now, then I'll also, you'll expect me to send the material tomorrow and day after. And it's just something that we don't follow in the company. We just make sure that we send all the material at once and it'll be sent only at the end of the webinar. Yes, so the codes, you guys anyway will be, pushed into various internships and all that. So you'll be dealing with different projects. Some of the projects you might have seen here, some of the projects you might have not. So you'll be getting the codes for that. Yes, and apart from that, you'll also be getting the codes that I mentioned today, with respect to the random forest classifier and the linear regression model. So it's going to be a 2 month internship. So you'll be working on a particular project for 2 months. We'll basically be judging you depending on the quality of work. Okay. So we don't have any specific time that you need to give us every day. You can give as much time as you want. Obviously, the more time you give, the more you're going to learn, and the higher the quality of your output will be. And essentially, what is going to happen now is that we're going to have the internship until the 31st of this month. Okay, we'll be starting it tomorrow or day after, and we'll have it until 31st of this month because after that, your colleges might reopen after the COVID-19 break. In case your colleges don't reopen, then you can still continue doing the internship. And in case they do, then what will happen is that your total duration of the internship will be 2 months. So assuming you work for 1 week right now, you'll only have to work for another 1 week and 1 month and 3 weeks after your NSEM exams are done. So that will be the layout of the internship, and over the whole course, you'll be working on various issues and things that we put forward to you guys. Okay, and we'll be using GitHub for everything. Okay, in terms of uploading code, sending in pull requests, and all of that, we'll be using GitHub only. And yeah, I mean that is. Pretty much the layout of the thing. I mean, that's what I understood about layout. If you have something in specific, then sure, you can ask me more about that. I hope I was able to clear your doubt. Sure, that works. So, any other questions, anyone?
Yeah. Can we deploy our model on IBM Watson Studio?
I'm sorry, I can't hear you.
Can we deploy our model on IBM Watson Studio?
Uh, your voice is really faint. Can you just type it out if you don't mind?
Yeah.
See, deployment can be done anywhere and everywhere, to be honest. Okay, yes, IBM Watson Studio is also a place where you can deploy, but your deployment should be meaningful, right? So you need to make sure that your model can be used by anyone, anytime kind of thing. So if that is the case, then definitely you can still, deploy it on IBM Watson Studio and make sure that you start sending API requests and things like that whenever you want to use that particular model. Any other questions, people? Okay, in case you guys have no other questions, then it would be great if you guys just give me a feedback as to how you felt today's session to be. Would be great if you guys could just type a line or two about what you thought about today's session. Would be great if everyone could do that. Guys, in case you have no other questions, then please would be great if you could, just tell me how you thought about what you thought about today's session. Was it helpful? Did you guys learn something out of it? Is there something you would want me to focus more on, or is there something you want me to change, or something like that? I just need an honest feedback from you guys. Yeah, see, so for the AI people, you can choose what project you want to work on. Okay, we'll have like machine learning and AI projects. You just have to tell your area of interest, and accordingly, we'll put you in a project of that sort. Yeah, so I mean, exactly as I said. So it depends on your interest. So if you want to work on a machine learning project, then you can. If you want to work on a deep learning project, you can. So the AI people will ask you for your preference before before we start pushing you for the internships. Thank you, Atisham. What about the others? It'd be great if you guys could just spare a minute to give some feedback. I see 22 people online, so it'd be great, if at least half of you tell me how you felt today's session to be. Thank you, Atisham. Means a lot. Thank you. Thank you. Razak, I'm really sorry. Unfortunately, it's just that we had quite a lot to cover, and probably I was a bit fast, but I'll try to reduce the pace of you from tomorrow in case you're in the AI session. Uh, okay, thank you for that. I'll try to give you guys a picture probably tomorrow if possible. Okay. Mention not fast. Thank you. I'm glad that you liked it too. So, thank you everyone for the feedback. Tomorrow we're going to see the basics of deep learning. Okay. So we'll be dealing with some mathematical aspects of deep learning and what exactly is deep learning. We'll understand the structure of deep learning concepts and all that. So that's what we'll be doing tomorrow. Uh, okay, so see, that's the thing. So it's just that thank you for the feedback though. And with respect to elaborate information, it's just that we want to make sure that we get more attendance for the sessions, because if we start dispersing everyday material, it's not really going to be feasible for us on the back end as well. So we just want to make sure that you guys so we give all the material at once, so that it's easier for all of you to just go through it as well, and it's easier for us to disperse it to everyone as well. So unfortunately, we won't be able to give you day-to-day material, okay? But we'll be giving you all the material at once. However, yeah, so it's like, if you want information about what is going to happen tomorrow or day after, I obviously give that information one day before, one day in advance. Even yesterday, I told you guys what we'll be covering today. And even today, I'm telling you guys what we'll be covering tomorrow. So that's the most we can do. But about the material, we can only send it after all the sessions are done. Really sorry about that. Yeah, so about the WhatsApp group, we actually won't be using WhatsApp anymore because we'll be using something called Slack. Okay, so Slack is a platform where we'll be taking up all the internship queries, and we'll see how everyone is progressing through codes and all that as well. So we've already created a Slack group, and that is the reason why we haven't really updated the WhatsApp groups, because we wanted to make sure that everyone joins the group on Slack. So we'll be sending you invites for the we'll be sending you an invitation link which you can use to join the Slack group. And yeah, you'll be able to see what is going on with respect to projects and all that as well. Thank you, Aisha. Thank you, Fatima. So the AI people, yes. So if you signed up for the AI part, we will be dealing with more more topics related to AI and some codes as well. Yes. Thank you. I'm glad, Saida. I'm really glad. Okay, cool then. So, thank you so much for the feedback, everyone. This really helps me a lot. It'll help me, even plan tomorrow's sessions as well. So, yes, you will get hands-on practice during the training session because it's a proper internship program. Okay, so you'll be given some tasks and you will actually have to write code and all that for that. So it's going to be a proper hands-on session for sure. Cool then. So it looks like, okay, so it looks like most of you don't have any other questions. So in case you have any other questions, feel free to WhatsApp me or call me anytime. Okay, and I think we can wind up today's session. Thank you, everyone. Thank you so much for attending today's session. Good night.